So starting with a full tank of gas, the distance traveled by a particular car is this equation, where D is measured in miles and G is the amount of gas consumed in gallons. So the first question asks us to compute the rate of change dd over dg and what units are associated with the derivative and what does it measure. So in order to find the derivative of this, there's two laws that we need to take into account. There's rules. There's the sum rule and there is the power rule. So the power rule states that the derivative of f at x plus g of x is equal to the derivative of the first plus the derivative of the second. And there's the power rule which states that the derivative of x to the n is equal to n x minus x n minus 1. So now we use these two rules to solve the derivative, which is d of 0.05 g squared plus 35g over dg is equal to, so the derivative of the first, which is d 0.05 g squared over dg, plus the derivative of the second, which is d over dg of 35g. So now we use the power rule, so the exponent goes down, so you have 2 0.05g, and then it's 2 minus 1, but I'm not going to write it down for the exponent, and then plus you bring down the coefficient, so 35, the exponent is brought down, which is 1, and then you have g, and I'm not going to write it down, so now you have 0.10g plus 35 is the derivative, so which is the rate of change. And now the question asks us what the units are associated. So since we have here the rate of change, we know that it's miles, which is the distance, over g, which is gallons. And what it represents is the rate of change of miles driven per gallon of gas that the car consumes. Okay, so the next part of the question asks us to find the value of the derivative for g equals 0, 5, and 10 gallons, and what do your answers say about the gas mileage for this car? So we have to recall that dd over dg was found to be 0.10 g plus 35. This was from calculating in the last question. So now we just sub in. So you have g equals 0 will give us a derivative of 0.10 times 0 plus 35, which is now equal to 35. And we have to include the units, which is miles per gallons. So when g is equal to 5, you do the same thing. Times 5 plus 35, which is bigger than the one before, but I'm going to get to that soon. And then the last one, g equals 10. Again, we calculate the derivative by subbing in the value. Times 10 plus 35, which is now equal to 36. So as the number of gallons increased by 5, there was an increase in 0.5 from the rate of change. So now we can make a statement about that. So we can say that the gas mileage, which is the rate of change, which is dd by dg, increases as the car drives longer distances. Okay, so the last question asks us what is the range of this car if it has a 12-gallon tank. So you just use the equation from the original question, which is dg equals 0.05 g squared plus 35g. And now it's easy, you just do some plugging in. Has nothing to do with any derivatives, which is 12 squared plus 35 times 12. And you find around 427 miles.